everyone, welcome to my session. I am Dominic Sales, one of the EdTech coaches from Xavier School, and I also teach 3D design, computer programming, and coding and robotics. So my topic is all about using online simulation tools to promote coding and robotics during an online distance learning setup. So let's move on. All right. So learning has always been a continuous process. It requires different forms from traditional to non-traditional, from the basic to the latest approaches or theories brought about by the latest innovations and technology. The traditional concept of teaching in schools or at home, though still may be considered a later trend, has leveled up into an online or virtual learning through the web, and making it the latest trend of teaching and learning. Technology in general has been giving the community a very significant contribution in the development of simulation tools necessary for teaching any subject, computer programming and coding and robotics, among others. There are no proven formulas establishing the most effective approach of teaching any subject or any computer subject. Notwithstanding this, the availability of online simulation tools for teachers and learners and the possibility that teaching would be a lot more interesting and fun in a very non-traditional way, though it might be a bit challenging because this is something new to all of us, are just some of the important roles of online simulation tools in teaching any subject. Moving on, when we say simulation tools, these are simply applications or software that allows the user to perform a simple task or any task without actual performing it in a physical setup. Okay? So simulation tools has been the major key in transforming education and training. So moving on, I'm going to share with you the different advantages of using an online simulation tools or in general simulation tools. So first one we have here, interaction between learners. Using an online simulation tools, your students or your learners can now share, interact, and collaborate with each other. Another one is that learning can be done regardless of time or place. Though, again, it's a bit challenging to all of us since let's face the reality that not all of us has this very good internet connection and not all of us has a device. But when we say simulation tools used in education, you can learn and you can teach anywhere or anytime at your own pace or at your own place. And the last one is learners can train and experiment multiple times. Considering the traditional setup, let's say for example in science or in chemistry, we have this feeling that we might mess up during experimental operations or during experiments. For example, you might you might broke some materials during experimentation. But using an online simulation tools or simulation tools in general, you can experiment multiple times and you can learn from those mistakes and experimentations that you have done earlier. Okay, so these are just some of the advantages of using a simulation tool in education. So moving on, the question here now is, can you use coding and robotics to teach other subjects? Or can you teach the topics from other subjects using these online simulation tools? The answer is obvious, and the answer is yes. So I'm going to share with you the different topics which I believe can be integrated in coding and robotics, and you can use these simulation tools to teach those topics. All right. So use robotics to teach different subjects. We have in mathematics the number coordinates, axes, degree angles, shapes, unit of measurements, variables, data types, and operators. So you can actually teach different topics in mathematics using these online simulation tools and using, of course, computer programming or simply coding and robotics. You can also teach physics in coding and robotics. For example, if you have topic using the speed, velocity, measuring the force, the displacement, and dynamics and control. Also, in science, you can use the different sensors like the light sensor, the color sensor. You can measure motion waves, heat energy transfer, energy in general. You can also monitor the temperature and humidity of the environment. You can also track or trace earthquake sensing and natural occurrences. So these are just some of the topics from other subjects wherein you can actually use coding and robotics to teach those different topics in the different subjects. Okay? So moving on, I'm going to show you the two simulation tools which I believe can be very significant in teaching coding and robotics and integrating other topics from other subjects. So examples of simulation tools in coding and robotics. We have the first one here. We have the VexCode VR. So I'm going to explain first the features of VexCode VR, and then later on we'll proceed with the actual programming and actual programming. So the VexCode VR. So basically the VexCode VR is very easy to use platform. So it lets you code a virtual robot using a block-based coding environment powered by Scratch or Blocks. So it means to say that this is simply a drag and drop. All right. Also, it is a web-based, which means to say that no software installation required. VexCode VR works in all major desktop and tablet browsers, but make sure that you have an internet connection so that you can be able to simulate the robot movement. Next one, we have here the virtual robots. So these robots are pre-built, which means to say that it has different sensors, but you can calibrate the sensors. So use drivetrains to navigate. Use sensors to help solve mazes. Use spend features on the art canvas to code a creative drawing, which means to say that you can also teach arts using this type of simulation tool. Use the new electromagnet to interact with game objects in challenges. And one of the most one of the features which I like the most in VexCode VR is the virtual playgrounds. So you can choose from different virtual 3D playgrounds to take advantage of the virtual robots features. You can control your point of view as the robot runs your code. Playgrounds include a grid world and art. So these are just some of the platforms or playgrounds available in VexCode VR. So let's move on to the environment of VexCode VR, and I'm going to show you how to use the VexCode VR. Alright, so here all you need to do is to simply open your browser and type vr.vex.com. Again, it's vr.vex.com. So let's just familiarize the environment of VexCode VR or vr.vex. Here you can see the different the different components or commands used in programming. So we have here the drivetrain, the magnet here, looks, control, sensing. So which means to say here these are the available sensors, the operators. While considering the operators, you can actually teach mathematics, variables also, blocks and comments, wherein you can add comments so that the user might be able to understand the role or what is the code all about. Okay, so here, the bigger area, the white area, is actually your sketch, wherein this area is where you place your all of the commands, or all your programs. Also, one of the features here, you can see here, you can create a new project. You can load from your device. So for example, you program the device to move forward. You can actually load the program from that device, and then open it in Vexcode VR. And you can also see here, you can also open examples and save to your device and about. So let's try to click open examples. Under open examples, you can see here the different examples categorized. So for example, we have here the drivetrain. So if you're new with programming and coding and robotics, this one is very easy to use, and I think you can use this to start learning coding and robotics. So under drivetrain, you can see the example: adjusting drive and turn velocity, change drive velocity forward and backward, draw a right angle. Also, we have here the looks, so you can integrate arts here. Also here in control, it talks about more of like decision making. Also here is sensing. As what I've said earlier, Vexcode VR or the robot has different sensors, okay, operators for decision making, and variables. So let's go back to its environment. So one of the features of Vexcode VR, which I like the most, is that you can check the activities here. Except from the tutorials and examples, you can also check the activities. Here, in the activities, you can see there are different activities wherein you might want, or you might ask your students later on for them to try during their spare time or break time. Okay, you can see here basketball drills, castle color match, coordinate numbers. Oh yeah, coordinate numbers, you can integrate mathematics here. Okay, so navigate the VR robot to a specific position using coordinates. So let's click this one, and let's see the activity example. Okay, so here it says here that this activity is for advanced students. So maybe you can use this example in teaching your high school students or senior high school students. So coordinate numbers, playground is the number grid map. So for the level 1, you can see program the VR robot to move to the coordinates -500 millimeters and 700 millimeters. On which number does the VR robot stop? So these are just some of the activities wherein you can answer. Okay, so let's go back to the environment of the Vexcode VR. Also, as what I've said earlier, one of the features of Vexcode VR is that you can choose the different playgrounds. Okay, so here the standard playground is actually the grid map. Okay, so let's just wait for the program to load. Yeah, there you go. So you can see here, you can reload the program, you can play, you can see the different heading, rotation, the front. These are the sensors, the location angle, the bumper, and the distance. So the bumper and distance is actually those are some of the sensors available attached in the virtual robot. Also, you can change here the point of view and the view. All right. So let's try to create a program using this Vexcode VR. So when starting, you always start with this command when started. So let's pick drivetrain first. Let's try to program, and let's try to move the robot forward. You can choose between forward or reversed. Okay, so let's choose forward. And also you can change the value here, 200, maybe let's make it 20. For the unit of measurement, you can use inches. Alright, and then after that, maybe let's stop driving. Okay, so now let's say for example this is your final program. You can now play your robot, and as you can see, your robot will move from point A to point B. Okay, so we set that the displacement is 20 inches. All right, so restart again, and again you can change the view, and let's try to play it again. So that's our robot now. It's moving from point A to point B. Okay, maybe we can add more commands here. So let's try to turn the robot, turn right for 90 degrees, and then maybe drive forward for again 20 inches. And change it to 20 inches, and then stop driving. And then let's try to play it again. So you can see the robot will move 20 inches and then turn right and then move 20 inches. So one of the features of VexCode VR is actually the marker or the pen wherein you can trace the movement of your robot. So I'm going to show you that. So look for the call this one the set print color and move robot pen. Also you can see here the set robot pen to color. So let's add the set print color. Let's maybe change this to green and move robot pen down. Okay, and then add this one, then restart and then try to reload the program. Then as you can see here, you now have the pen or the marker wherein it will trace the movement of your robot. Also, you can integrate physics here. You can change the velocity or the speed of your robot. So let's look for the velocity here. I think it's something down. Yeah, it's here. The velocity, set drive velocity to specific percentage. So yeah, we can change this to make it this 100. Okay, and then let's try to run our robot again. So you can see that the robot will move faster compared to the initial velocity speed, which is 50%. Okay, so if you want to learn more about VexCode VR, you can just search the internet or open vr.vex.com and start the tutorial or the different examples available in VexCode VR. So this is the VexCode VR. I hope you learned something. And the next simulation tool which I want you to know is, or to learn, is actually one of my favorite simulation tool, which is the Tinkercad. Well, actually, I'm using this to teach coding and robotics. So Tinkercad is a free online collection of software tools that help people think, create, and make. So I'm going to show you the things that you can do with Tinkercad. First, we have here the design. So place and wire components to create a virtual circuit or begin with a starter. So which means to say that Tinkercad can offer different basic circuits for you to be able to learn. Okay. Also, we have here the program. It is capable of using both blocks and text. Program using code blocks or C++. You can also simulate and see the components will respond in real life. So it's similar to VexCode VR, but then Tinkercad is much, I think for me, is much what do you call this one, beneficial in my part because I'm teaching electronics also, coding and robotics. And some more features you can build, program, and enhance your setup, your circuit or your robot. So except from teaching electronics in using Tinkercad, you can also teach 3D design here, which is really good, right? So you can just create new design or create a new circuit, code blocks, and you can see here there are different lessons available in Tinkercad. So of course, moving on to my forte, which is coding and robotics, I'm going to show you how can you integrate mathematics, physics, science, and maybe electronics in a simple setup or in a simple circuit. So for us to be able to create a new circuit, you simply click circuit and create new circuit. Oh, by the way, Tinkercad is free. You can create your account. You can choose between personal or student or teacher. So I'm using a personal account here in Tinkercad. Alright, so this is the environment of Tinkercad. As you can see from my from my right corner, these are the basic components which you can use in designing your first circuit. Alright, so you can choose also if you want to view all the components here. So these are the different components available. Okay, so let's go back to basic. Here in this area, this is where you design your circuit. Okay, so let's just familiarize with the environment of Tinkercad. You can see here at the left corner, this is for rotation. So if you want to change they call this one the rotation or the arrangement of your components, you just simply select your component and press the rotation. Also, you can delete the component. You can undo and redo. Of course, these are just some of the parts of the Tinkercad. Here you can see the code. So since we have no circuit available yet, so we cannot load the program, you can start simulation. Once you are done with your circuit or your program, you can just simply press start simulation. You can also export your program and share your program for collaboration. Okay, so now I'm going to show you a basic circuit, and we're going to add the code and start the simulation. Okay, so I'm going to show you how to blink a LED to measure the temperature and to notify the user that the temperature is actually increasing using an LED. So let's try to add a microcontroller board, which is available here is the Arduino Uno R3. So to do that, you simply select the component and drag and drop to your sketch. Okay, so here is we have the Arduino Uno, and of course we need the breadboard. Okay, and again, let's try to create a basic circuit wherein let's try to turn on an LED using the program. Okay, of course, in doing that, we need a resistor and an LED and some wires. So let's add a resistor. Okay, for the physics teachers, I know you know what is the function of resistor. So basically, when we say resistor, this is to resist, to control the flow of electricity. Okay, let's add an LED, and I'm going to rotate my LED. Simply select the LED and press the rotation here. Okay, and you can also change the name of your LED and of course the color. Maybe let's choose green. Okay, and then let's move our LED, position it. So there are two legs in your LED. We have the cathode and anode. So the positive wire here is actually the anode and the negative is cathode. So let's position our LED. Okay, insert the cathode in our negative and the anode are positive. Let's connect this one to our resistor here. So remember that when we say resistor, again, it has no polarity, meaning it has no positive or negative. Okay, so we're done with the connection. Let's add, of course, we need a power source, which means to say let's connect a wire here from your breadboard going to your Arduino Uno. Connect it to GND. So when we say GND, this means it's a negative. And when we say it's negative, the proper color code should be black. Okay, let's change to black. And also we need to connect our LED to a digital pin. So let's connect. Maybe we can choose digital pin 13 for the meantime. Okay, and no need to change the color. Okay, so this is our basic circuit. Okay, let's try to simulate the program and see what will happen. I'm gonna zoom this one. So as you can see here, the LED is actually blinking. All right, so it blinks because there is the standard code or the default program here in the Tinkercad platform. So to change the program, you simply press code, and you can see here the blocks. So what I'm going to do now is to change the platform, the programming platform, and make it text, and still press continue here. So you can see here, guys, that under your void setup, you have the pin mode 13 comma output. 13 here, it is simply because we use pin 13 in our Arduino setup. So if you use other pins or other digital pins, let's say for example digital pin 7, then your pin mode setup here should be also 7. Okay, so output, it is because LED is an output component, so it produces light. Okay, so under your void loop, we have here 4 lines of codes. The first 2, okay, we have here the digital write 13 comma high and delay 1000, which means to say that your LED will turn on for about 1 second, because it's 1000 milliseconds, so it's equivalent to 1 second, and after 1 second it will automatically turn off. Okay, so you can change the delay. Let's make it maybe here 500 and here 500 also, and let's start simulation and see what will happen to our LED. As you can see now, our LED will blink faster than the usual one. Okay, so that's the basic of Tinkercad. Now I'm going to show you that you can actually integrate science and physics here. So this is a quite interesting part, because I'm going to program the sensor wherein it will display the value of the sensor. Okay, so let's look for the temperature sensor. Here we have the TMP36. Okay, so first you can see here that there are 3 wires available in our temperature sensor. We have the power. This one should be connected to our positive or from the 5 volts of our Arduino Uno. Also, we have the V out and we have the GND. For the GND, again, this is negative. For the V out, this should be connected to our digital pin. Okay, so let's position our temperature here. Again, for the power, it should be connected to our 5 volts, which means let's connect this to our positive here, positive pin, and let's change the color and make it red. This one for the GND, connect this one to our negative and change the color to black. Of course, do not forget to connect our the V out. Connect this one to our digital pin. Maybe we can use the digital pin 2. Right, digital pin 2, and let's change the color and make it orange for the meantime. Okay, so now we have the correct schematic diagram. We are now ready to code the sensor. Going back to code, of course we need to declare the command wherein we can it allows us to display the value of our sensor in our serial monitor. So simply type serial.begin 9600. Okay, if you're new to coding and robotics, guys, I suggest that you visit arduino.cc for you to be able to learn the different syntax and patterns in doing Arduino programming. Okay, let's just remove this first. Okay, we have here the serial.begin 9600. This means to say that this is actually the baud rate or the connection between your Arduino and your computer. So let's display the value of our sensor using this command serial.begin or serial.println rather ln, and the value of our sensor. So remember that our sensor is connected to our digital pin 2. So let's use the command digital read and then the digital number, which is 2, followed by the ending, which is the semicolon, and let's put some delay here. Okay, delay, let's say delay 200. And of course, do not forget to initialize our pin. So pin mode. Okay, that's 2, and our sensor is an input component, so type input here. Okay, so remove this first, our LED. Now we are ready to run our program, and let's try to simulate our program here. So start simulation, and you can see here in our serial monitor the value of our temperature is actually 0. It is simply because we forgot to connect the power from our temperature sensor should be connected to the 5 volts. So let's just create a connection here, 5V, and yeah, insert it here in our breadboard and change the color and make it red. And maybe we can add more component. Let's try the, call this one, the, wherein you can use to measure the voltage of your Arduino or the battery. So you can see here there are two connections that should be connected. So the negative and the positive. So let's try to connect the positive in our breadboard here, positive. And for the negative, let's connect this one in our negative. And let's see what will happen to our multimeter. So let's press start simulation now. So you can see that it shows you the current voltage value of our Arduino Uno. So if you want to learn more about coding and robotics and Tinkercad or Arduino in general, you can actually visit arduino.cc, or you can search the Google or in the internet different resources available to learn Arduino and coding and robotics. So to end my session, okay, overall, online simulation tools has made incredible progress, and its original uses have expanded out of experimentation and disrupted and transformed methods of education, most especially nowadays during pandemic. So it's very important for us teachers and educators to use the appropriate and proper tool to deliver our lessons in an online setup. So with that, thank you so much for listening and for giving your time to my discussion. Thank you so much. So again, thank you for listening and giving your time to listen to my topic. We are now ready for the Q&A. And what we have here, we have from Miss Juvelin Doc Bono. Designing online distance learning is quite challenging, especially to those who are not yet computer literate. So my suggestion would be you have to start somewhere. Keep on searching for answers online. If you get stumped or confused by a computer program, you just need to search online. Number two is you need to practice what you know. A great way to enhance your current computer skill is to keep on practicing. And we have different free online course when it comes to computer literacy. Reach out for computer literate persons or those who practice this kind of profession. And one of the suggestions of my coworker in Xavier School is that you just simply keep an open mind, growth mindset. We may have our limitations, but always decide with the pedagogy in mind. So what will help your students in learning the best platform or strategy. So ask yourself, um, will learning some tech tools benefit my students? Or what simple ways or options do you have that you can start right now so that you can be able to start designing your own online distance learning? And another one here from Miss Everly Lubis Gonzalez Chavez. This topic is very helpful to me since the coverage of my lesson for the last quarter is robotics. It is very challenging on my part to deliver the lessons online without the physical kit. So thank you for this opportunity. Well, we have different simulation tools, offline and online simulation tools. Those two that I discussed, you can also download the WeBot. It's an offline platform. And to address the problems on resources, you can start with teaching your students how to do flow charting. So those are an example of offline coding or offline programming. So you can start with flow charting. Okay. So what more? So for you to be able to learn coding and robotics and use online simulations, I advise that you again start looking for free webinars like this or free online sessions like this. So, and also you can, yeah, questions here. How can we reach you out? So you can reach me in my Facebook account. It's Dominic Cabarlas Sales. I also have a YouTube channel which is RoboGuro. So you can find different tutorials I made for coding and robotics. Lately, I conducted a free 5-day session for coding and robotics. So you can check the videos in my YouTube channel. So what more here? So yeah, that's it. Again, thank you, Rex, for giving us this opportunity to share our knowledge on coding and robotics, and of course, for sharing what we know about designing and online distance learning. For you to be able to get your certificates, please do not forget to answer the feedback form. And again, thank you for tuning in our live session. Stay tuned for more learning activities like this. So goodbye, guys.